Hi, in this session we are going to look at the criteria for similarity of triangles. Okay, so very important session. We have already understood the criteria for congruency in your previous standard, so we have seen certain rules. Okay, so here what we are going to look at is certain rules for checking the similarity of triangles. Okay, so we know already that two triangles are similar if the corresponding angles are equal and also the corresponding sides must be in the same ratio. So let's say this is triangle 1 and this is triangle 2. So when can you say this triangle 1 and 2 are similar? See, this angle B and angle E should be equal. Then A and D should be the same. C and F should be the same. And after that, corresponding sides, that means AB and DF, these are the two corresponding sides, AB divided by DF, then BC divided by EF, and AC divided by DF. So all these ratios should be same. Okay, so when you need to say two triangles are similar, the corresponding angles must be equal and the corresponding sides should be in the same ratio. Okay, so that's the definition which is given here. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. I hope it is clear. Now, so what all things we need to check here? We need to check whether this angle, this one set of angle, second and third. So three angles we need to check. Then we need to check the ratio of three sides, right? Three corresponding sides. So all in all, you need to check 6 aspects, right? To know whether the triangle is similar. 3 angles and 3 corresponding sides. But the question is whether you need to check all these 6 aspects to know two triangles are similar or not, or is there any shortcut, or is there any other rule which you can understand whether the triangles are similar? Okay, like by checking 2 or 3 parameters, like we have seen in case of congruency. We have seen certain rules for checking congruency of a triangle. Okay, so in case of congruency, two triangles are congruent if all angles are equal and all sides are equal. Here all angles are equal but sides need not be the same or equal, but the ratio need to be the same. So you can derive certain rules for similarity here also. Now this session is actually dedicated for understanding certain rules, okay, and that we will study as one of the theorem. So let's look at that theorem and you will understand the first rule that we call as A criterion for similarity, or angle criterion for similarity. So let's look at the theorem. Okay, so here is the theorem. See the theorem 6.3, which states that two triangles, okay, in two triangles, if the corresponding angles are equal, then their corresponding sides will be in the same ratio. Okay, so if corresponding angles are equal, then their corresponding sides are in the same ratio, so you can say two triangles are similar. So if you need to check these two triangles are similar, 1 and 2, or we can prove this by using these two triangles ABC and DEF. Okay, and this criterion is what we call as AAA, or angle criterion for similarity of triangle. So let's see how you're going to prove this criterion. Okay, so let's take two triangles ABC and DEF. ABC is the small triangle, DEF is the large triangle. What is the condition? Angle A should be equal to angle D, angle B should be equal to angle E, angle C should be equal to angle F. Okay, so this is the condition. Now what is the conclusion? The corresponding sides should be in the same ratio, and that's what we need to prove. So corresponding sides should be in the same ratio means what we need to prove? The ratio, that is AB divided by DE, these two corresponding sides, equal to BC divided by EF, these two corresponding sides, equal to AC divided by DF, AC divided by DF. So this is what we need to prove. Okay, now let's see how we are going to prove it. Okay, so what you need to do is, this is triangle 1, this is triangle 2. So try to visualize triangle 1 in triangle 2. That means construct a triangle 1 in triangle 2. What you can do is, take this length AB, take that length here and mark a point P. Similarly, take this length AC and mark that length AC on PF, that side PF, which is Q. So P and Q you marked. So I hope you understood. P is actually the length of AB and Q is actually the length of AC. Both are from D. Now join PQ. Okay, you join PQ. So you got a triangle. So these two are now congruent. Why? Because all the angles are same and all the sides are same. So you can write triangle ABC and triangle DPQ are congruent. Okay, so this and this are congruent. Why? Because the angles of the two triangles are equal and the sides are also equal. Now angle B equal to angle P, this is equal to this, okay, and which is equal to E. That's our initial assumption. Angle A equal to angle D, angle B equal to angle E. So angle B and angle E is equal. So this is also, because this is what we have taken, the same length is what we have taken, and then this is parallel, right? So you can clearly understand PQ parallel EF. Okay, now when you understood that PQ parallel EF and EF is one of the side of the triangle and PQ is parallel, and that parallel is touching the other two sides, so what will come to your mind now? BPT, basic proportionality theorem, right? The parallel of one side is touching the other two sides of the triangle, the ratio will be equal. So clearly you can write this DP divided by PE equal to DQ divided by QF, and that's what you have written here. So I hope you understood this. So answer for this question Y, if you see, that is basic proportionality theorem. From that you can apply this, or you can write this. That is also application of basic proportionality theorem, and we have seen that in the previous example. Now if you still need to know how you wrote this, just do this, just invert it. Okay, so this one you take it here and invert it and write it as PE divided by DP is equal to QF will come right on top, QF divided by DQ. Okay, now once you invert this, what you need to do is, there is no change now because both sides you did the same. Okay, now add 1 on both sides, then also no change because you are making the same change in both sides of the equation. So what you can do now is add 1. PE divided by DP plus 1 is equal to QF divided by DQ plus 1. Adding 1 means what? Effectively you can write this as PE plus DP divided by DP, okay, is equal to QF plus DQ divided by DQ, right? So now what is this PE plus DP? You look at this triangle, this is PE, this is DP, so the together will get DE. Okay, so you can write DE here, DE, okay, divided by DP is equal to, what is QF plus DQ? QF is this, DQ is this, so together that is DF. So you can write here DF divided by DQ. Now remember, once you inverted here, let's re-invert it. Okay, so then when you invert this, you will get dP divided by dE equal to dQ divided by dF. Now what is dP? See here, dP is this, right? So dP is equal to AB. So you can write, instead of dP, it is AB divided by DE is equal to, what is dQ? See here, this is dQ, which is equal to AC. So you can write it as AC divided by dF. And that's exactly what you have written here. So I hope you understood from basic proportionality theorem how you are writing this. AB divided by DE equal to AC divided by DF. Okay, so what is AB? AB is this. AB divided by DE equal to AC divided by DF. So two sides are in the same ratio that we have proved. Now we need to see the next also. What is that? BC divided by EF. That's what we need to do. So what you need to do here is, in the same triangle, see the smaller triangle DPQ, you need to slide it to the bottom such that this P will come and sit on E. Okay, so P will come and sit on E, and Q will sit somewhere here. This D will come and sit on somewhere here. Okay, so basically you're sliding the triangle to the bottom such that P will come and rest on E. So how will you redraw that? Let's suppose this is the initial triangle, that is E, F and D. What I told you is to slide the smaller triangle to the bottom. Okay, now when you slide that, D will come and rest here, this D will move here. So I can mark it as D dash. Okay, it's actually D. Let me mark it as D dash. Okay, now what will happen here? P will come and sit here. Okay, now Q will come and sit somewhere here. Okay, so this is the two triangle you got. Now remember, this Q D dash is parallel to DF. Okay, so this and this are parallel. So once these two are parallel, again you can apply basic proportionality theorem. So obviously this angle and this angle is same. Angle D dash equal to angle D. Okay, these two are parallel, so corresponding angles. Now you can apply basic proportionality theorem here. Okay, so you can get this divided by this equal to this divided by this. So all those things you already know. From that you can write, see here, one more thing which I need to tell you is, see, if you look D here, what is D here? A. So you can write, instead of D, A, here also you can write A, because that A you are sliding to the bottom. Okay, now what is P? P is actually B, so you can write B here. Okay, what is Q? Q is actually C, so you can write C here. So what is our ABC now? This is A, this is B, this is C. Okay, now if you apply basic proportionality theorem, what you can write is E D dash divided by E D. Okay, that is, this is E D dash divided by E D means the total. Okay, so this much divided by total is equal to this EQ, right? This much divided by total, that is EF. I hope it is clear. So which is equal to EQ divided by EF. Now from this clearly you can understand that E D dash means what? That is A and B. So instead of E D dash you can write A B divided by ED is equal to, okay, what is EQ? This EQ you can clearly understand that BC, right? So you can write BC divided by EF. So what you got is actually AB divided by ED or DE equal to BC divided by EF. So if you consider this as first equation, AB divided by DE equal to AC by DF, and this as second equation. Okay, now considering 1 and 2, or from 1 and 2, what you can write here, AB divided by DE, AB divided by DE equal to AC by DF. Now here you understood AB divided by DE equal to BC by EF. So you can write BC by EF. And that's exactly what you need to prove, and that's what the angle criterion. So three angles are same or equal means the corresponding sides will be in the same ratio, and that's what exactly you have proved over here. I hope it is clear for all of you. Now one more point, see, if you see here, let's take two triangles. Okay, so let's take two triangles. So if I say this angle and this angle is equal, and this angle and this angle is also equal, automatically this two will be equal. Why? We know angle sum property. Okay, so 180 minus these two sides will be this, and since these two sides are equal to these two sides, okay, 180 minus the two sides will give you this also. So these two will effectively be the same by using angle sum property. So you don't want to know three sides. Even if you know two sides which are equal, you can apply this property or theorem. So that's what discussed here. If two angles of triangles are respectively equal to two angles of another triangle, like in this case, okay, then the angle sum property of a triangle, their third angles will also be equal. So third angle will be equal. So you can rewrite AAA similarity as this. Okay, so what it is saying, if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. So you just need to check this only. This is one triangle, this is another triangle, this angle and this angle equal, this angle and this angle equal, then this triangle is, these two triangles are similar. Why? Because anyway this will be equal. Now if all the three are equal, corresponding sides will definitely be in the same ratio. Okay, that's the assumption. So if two angles of one triangle are respectively equal to the two angles of other triangle, these two triangles are similar triangle. So this may be referred as AA similarity criterion for two triangles. Okay, so now AAA means angle. So if you know three angles, AAA. Even if you know two angles, just need to write AA criteria. I hope this is clear for all of you. Okay.